much. Thank you very much for that kind introduction. And thank you, Paul, for inviting me down to talk to the section.
You sharing?
Yeah, everything's getting shared. That's great. So yeah, Getzner, based over in Austria. We produce polyurethane materials for the railway industry, the construction industry, and also industry, shall we say, where we can isolate noise and vibration coming from heat pumps, air conditioning units. In construction, we can isolate full buildings. But of course, we're going to focus on railway today. So our core competencies are vibration isolation, superstructure protection, and noise reduction. But we also do services, and that's where we can assist with specifying the best solution. If you've got a problem, then we very much want you to come to us, and we can specify the best material, we can show you what's possible to achieve. But so far in the UK, our number one product is mostly focused on superstructure protection. So the 6 main products we have for the railway superstructure are under ballast mats, under sleeper pads, rail pads, mass spring systems, insertion pads for booted sleepers, and base plate pads. But today I'll just focus on 3 of them, which is sleeper pads, ballast mats, and mass spring systems. So something we always ask, why under sleeper pads? Why do we want to put that elastic layer at the base of the concrete sleeper? Well, you either do it for vibration isolation, and that tends to be a thicker pad, a more elastic pad, or we do it for ballast protection. And the reason we do it for ballast protection is because ballast is the weakest component. It is always the first part of the track to deteriorate, and this can cause lots and lots of problems. By the ballast crumbling against the concrete sleeper, it turns to dust. This can give you lots of problems in terms of drainage. If the water can't drain away, it can lead to voids underneath the sleepers. If it does drain away, then you've got uneven settlement, uneven load distribution, and you've got the voids underneath the sleepers. Also, with the changing pressures and the stresses on the sleepers due to not being supported correctly, sleepers can end up cracking. And often we find the part you'll notice is in transition zones, when your track has went from when there's a change in stiffness in the track. So on the image here, you can see the white spots from where the ballast has turned to dust and then risen up towards the top. And this often happens faster in areas, as I said, with transitions. So they've went from bridge deck using timber sleepers much longer. So you have that really stiff surface with the bridge deck, and then onto the ballast and the subsoil. So we call that the white spots, but you could also call it a hot spot, so you can. And all of the things I've mentioned inevitably lead to poor track quality and uneven settlement. So how do we solve this? Well, we solve it by attaching the under sleeper pad by either the mesh layer, or you can see here the flock layer. And I just want to we've got it on the screen there to make it to put a bit of stress on. Our materials are all polyurethane, and it's not to be confused with rubber. The properties of rubber often change over time, whereas polyurethane will last the lifetime of your track. So to install them, very easy to install at the sleeper manufacturers. Once the wet concrete is poured into the moulds, you simply just place the pads and push the mesh side into the concrete. And once attached, you'll end up with something like this. You have your sleeper pad on the base of on the sleeper, and what it does is it allows the ballast stones to embed. So we define how much embedment there is, depending on what we're trying to achieve and the different range of sleeper pads we have. But allowing the ballast stones to embed increases the contact area. So on a non-padded sleeper, the contact area is normally between 3 and 5%, whereas with the additional embedment, additional contact, it can be up to 15 to 35%. Another way of looking at that is you're increasing this contact area by tenfold, and you're decreasing the actual ballast contact pressure. So the contact on the individual ballast stones by up to 85%. Couple of images just to show you how the contact area is improved, and you can see quite clearly the ballast stones have embedded rather than just sitting grinding against the sleeper itself. Another thing just to make a point on is our material has an elastoplastic behaviour. So once the ballast stones have moved, if you ever have to go in and tamp, once you do tamp and move the ballast stones around, the ballast will then find its new location where it sits, and the material will come back to its original state, which is quite important when it comes to the likes of using sleeper pads. Just another image there, you can see on the left-hand side in the unpadded area, the ballast stones after 100 million gross tons is starting to deteriorate, whereas on the right-hand side with the pad, it's still perfect condition. Another view giving you the same idea. And how it works, so by increasing the contact area, you can activate more load distribution with the sleepers pads, because with the contact area, you're spreading the load over a much larger area. So on this slide, you can see you're using around about 7/8 sleepers, whereas without sleeper pads, with the poor contact area, the load is distributed over roughly 3 sleepers. So it's that angle that you're increasing. We had a test track over in Austria, and you can see here the yellow line is a straight track without undersewer pads. Green is the part of the track with the station on it. The blue is the section with undersewer pads, and red again is the straight track. So it was all one line, just different sections of the track. And they looked at the deterioration rate of the tracks and the tamping cycles. So what they found was on the area of the straight track between 2001 and 2021 had to be tamped 3 times. The area was tamped 3 times. The area with the undersewer pad only had to be tamped once, and this was only tamped, it was still within the limits. It was only tamped because after 10 years, they have a requirement to tamp the track. So it was still working perfectly fine. And the last part, the straight track again was tamped 3 times over the course of that period. So an evaluation of more than 1,500 cross sections in Austria, with more than 20 million gross tons, equipped with undersewer pads, showed an increase of tamping intervals by a factor of 2.75, which is almost the kind of 3-to-1 that I showed you in the previous graphs. A reference that we're very proud of at Getzner is from the Daking fuel line over in China. This is the line with the highest tonnage in the world. It has 580 million gross tons annually. If you compare that to Austria with 25, you can see it's a huge difference, 25-ton axle load, 650 kilometres long, and in just under, I think it's just over 2 years, 2.5 years, it accumulated over 1 billion gross tons. And we received an official reference letter that we were very proud of that stated that in the unpadded section of the track, tamping was performed 5 times, yet in the section where they did use our pads, the geometry and quality remain excellent today. But when it comes to network rail, This graph was created by some, I think it was Mohammed Webby from the track bed investigation team, and he stated that after the decision to install under slipper pads, you have that additional cost at that point, but every second, minute, hour after that is when you're starting to see you're saving money. So the increase in installation cost is 2.25%. You reduce track geometry deterioration by 20%, and the track life can be extended by 30%. I'm not sure how they got the figures of 300 million in 10 years and 3 billion over 30 years, but I'll keep them in there. So the next part is something we've just started looking at recently. Darren Sharp was very much in charge of this, and that was the lateral track resistance of the pads. If you've created greater contact, you've got that ballast stone embedded into the pad, well, it makes sense there's going to be a better grip, a better grip of the sleeper. So as part of one of his tests, we tested a variety of different sleeper types down at Southampton University. And what they done was they pushed the sleeper and they wanted to calculate how much force was needed to move the sleeper by 40 millimetres.
Laterally.
Laterally, sorry, yes, laterally. So the outcomes are, you can see on the table here. So the very bottom line is the EG47, the bottom blue line, the kind of dotted one, is EG47 without underslipper pads. And above that is the G, let me see. The next blue one should be the EG47 with underslipper pads, so you can see the increase. Oh, sorry, I'll look on this screen, maybe I can get the colour. No, sorry, the two blue lines. You have the G44 without underslipper pad, the solid blue line, and the dotted blue line is the G47 without underslipper pads. And then your two black lines is the increase. So the black line at the very top is the G44 with slipper pads. So you can see it's increased from 8 to maybe 14 kilonewtons. So you're looking at over a 50% increase. The next one I'll show you is in comparison to the lateral end resistant plates. So the black one at the top is the G44 with underslipper pads, and the blue one is without. So you can see there's a massive increase in lateral track resistance. But when you even compare it with the likes of the LERPs, you can see the G44 is either better or there or thereabouts. So discussions are taking place whether it's possible to stop using the LERPs. I know a lot of engineers find a lot of issues with these things. They can be expensive, hard to install. So conversations are still taking place, but it might be possible to use them instead of, or even reduce the amount of LERPs that are being used. So in terms of a standard, slipper pads should be specified in all category 1A, 1 and 2 track. But we're not quite seeing that taking place yet. As you'll know, in Network Rail, we've got 14 regions with all different budgets. So the decisions are being made separately on what products they're using. But in April 19 to March 20, we supplied almost 60,000 sleeper pads, 60,000 sleepers. The following year was nearly 80,000. The year after that was just over 110,000. We have London Underground, they're 100% on board using sleeper pads. And our most recent figures from 23-24 shows that we're around about the 140,000 mark. And as we're here in Wessex, yellow is good. So we're happy with the usage in Wessex. We're looking at roughly 30% of the sleepers having pads. You can see Scotland, North West, North East, they're high users. And I've got my kind of focus area on the likes of Wales, West Coast of the Main Line, to make sure they know the benefits of using them. So really the benefits are improved track quality, less wear and tear. You've got reduced maintenance costs due to minimised deterioration of ballast. You've got increased track availability, and you're extending the lifetime. Plus, you now have this additional greater lateral track resistance. In terms of turnouts, well, turnouts we see as they're seen as quick wins. Turnouts deteriorate faster. They've got the additional steel, the different lengths of bearers, the different forces. So by protecting the S&C, you get return for investment much quicker than sleeper pads. But at the moment, I think we're looking at around 60% of S&Cs for Network Rail have our pads. That's estimated from the concrete factories when we're speaking with them what they're doing. Again, London Underground are 100%. So same installation methods. Bearers with the pads are then transported over to the likes of Progress Rail or VAE, and they're manufactured into switches and crossings. But I did say they can also be used for vibration isolation, and I'm hoping this video will work and have sound, which can show you what's possible. I think there would have been sound by now.
Operating railway traffic without turnouts is impossible. They are complex and a significant cost factor in every railway network. Without the appropriate measures, variations in stiffness over turnouts and asymmetrical geometry cause uneven settlement and increased wear, or even tilting of the entire turnout. This subjects the ballast and other components, such as the frog and switch plates, to extreme loads. This results in higher maintenance costs and increased periods of closure. The solution from Getzner: introduction of defined elasticity. Using the finite element method, the effects of a train passing over a turnout are simulated. The model accounts for all geometric conditions, system stiffnesses and axle loads. Based on this, Getzner determines the right individual solution, one that provides the optimum stiffness graduation. Different types of sleeper pads, made from silomer or silodyne, balance the variations in stiffness across the entire turnout. Differences in deflection are leveled. For a more even passage of the train, more even settlement and more homogeneous superstructure behavior, tilting of the turnout is prevented. The large contact area provided by the sleeper pads leads to better load distribution, which protects the ballast. This results in an extended service life and longer tamping intervals, plus lower dynamic force within the turnout and less wear on all turnout components. Extended service life, lower maintenance costs, longer tamping intervals, higher availability, improved track stability, greater ride comfort. All this results in reduced life cycle costs and less vibrations and noise. The elastic bearing of turnouts by Getzner, engineering a quiet future.
So that little video gives you an idea of what can be achieved by using and changing the different elastic pads in a turnout. In all honesty, going to that many different is a little bit overkill. Maybe even just two is probably, it would make such a difference using two anyway. Trying to do five in the sleeper factory and making sure the pads are in the right place, delivered in the right place, maybe a little bit too much. Unless you're looking for the perfect solution, but it was just to let you know what's available. And often you can also change the elasticity in the transition zones. So if you again have areas on and off bridges, tunnels, you can replicate that elasticity by using the pads. So the benefits, I think already been mentioned there, but just a kind of summary or some considerations. Contact areas increased by 10 times, 85% less contact pressure, 60% less maintenance, 30% extension of lifetime of the track, greater load distributions, cheaper alternative to LERPs. It's possible to reduce ballast height. Shows whole life cycle costs and whole life cycle carbon can be reduced, and less boots on ballast is always safer. And greater track availability as we're moving towards more of a 24-hour railway. So the next section is underballast mats, and these are most often installed on railway bridges or tunnels. As you know, railway bridges are among the most important structures in the railway. If one bridge is to close, it can cut off whole parts of the country. So making sure these are working properly is extremely important. They can be used in sections of reduced ballast height. And what they're doing again is acting at bringing elasticity to where it's lacking. So if you have on the bridge, you see the stiffness changes from the subsoil to the really hard concrete bridge deck. You've got different heights and ballast, and you've got that sudden change of overall vertical stiffness, track stiffness. And that all of which results in faster deterioration of the track components. You've settlement, deterioration, track quality, and then in the end, all leads to having high maintenance efforts and costs. Currently, what we see that's already on the market only really focuses on protecting the waterproofing layer rather than bringing elasticity into the railway. So our underballast mats come in a 2-layer or 3 layers. I've only actually ever seen 2 layers, so 2 layers. One's a protection layer and one is a resilient layer. And this is what the part that comes with different thicknesses and different elasticities. And our products are for, we have products for all different railway types, whether it's urban, mainline. We have an underballast mat for all. An idea of how it would look in the end once installed. But to actually install the products, we deliver them in 1.5 metre wide rolls, and they can be rolled out. 1.5 metre wide rolls by 5 metres, and that's really just to try and keep the weight down so that they can be easily handled by one person to throw them down, roll them out, and then you can look at gluing them to the bridge deck. You can easily cut them with a knife. You join them together using cover strips and a heat jet gun, and in the end you have something that looks like this. And you can see there's been holes drilled in this one for the drainage. Once all installed, you can drive over them with a rubber tired vehicle. The only thing we would say is you wouldn't turn the wheel whilst in a stationary position. If you're driving, it's fine, but not in a stationary position. And then you can spread the ballast out onto the track. And again, what you're doing is you're increasing that contact area. There's a number of things we're doing here, but putting in a protection layer between the bridge deck and the ballast, so you're stopping that crushing, that grinding, similar to how the slipper pad was doing it. But we're also increasing the contact area and the elasticity, so we're reducing the ballast stress. But this next image, for me, is one that shows it the best. So if the train's going from a normal standard track with subsoil, say 300 mil ballast, standard subsoil, you have a certain elasticity within that track. But as soon as you get to that bridge deck, you've got less ballast height, you've got a real solid formation. So we would specify and calculate the correct material to use, and what you're doing is you're smoothing that out. You're to avoiding these hot spots and track deterioration. Now, the sales guys, the guys over in the US, were sending out this message, but the train operators didn't fully 100% believe them. So they said, okay, let's try your material on half of the bridge. Let's try and see what happens. So that's what they done. They installed the underballast mat on half of the bridge, and very quickly they realised that the section without underballast mat, there we go. There's those white spots that I've already talked about. The white spots ballast was heavily deteriorating, whereas in the section without underballast mat, the section with underballast mat was still in perfect condition. So now it's actually led them to use underballast mats on all new bridges. So they've obviously seen the results are positive. But again, products can be used for noise and vibration mitigation. We're seeing railway tracks closer and closer to where people are living. We have a project over in Germany. Now, the reason for this example to show you is the long-term behaviour of our products, but it gives you a little bit of the background. So they built a concert hall, Royal Orchestra concert hall, and this was situated very, very, very close to the railway track. So they got Getzner involved. Getzner installed underballast mats, really isolated that part of the track, and since then it's been working absolutely perfectly. There's been no complaints from the orchestra. They've really mitigated it. But the main point of this is to show you the longevity of the material. So it was 1983 they installed the underballast mat, and when we went back in to check it to see how it was performing, the underballast mat was completely underwater. There was a ballast depth of 18 centimetres, and it accumulated almost 1.5 billion load tons. We cut a section out in 2012 and we carried out our tests, and went back in again in 2000 and then 2012. And from this, you can see that the values of the material almost never changed over the course of the years. So we're looking at, is that 30 years almost? And the static stiffness of the material is still within original specification, and same for the dynamic stiffness. And I believe we're going back in again soon, if we haven't already, and we're going to carry out the same tests again. So till now, more than 5 million metres squared have been installed, all different track speeds, axle loads, conditions, track types, qualified by many test institutes, and we are the qualified supplier to many operators around the world. So the benefits of the underballast mats, of course, are for protecting the bridge deck, but what stands us out and apart from many of the competitors is how our products perform at such a high level, our long-term references, our wide experience, the ease of installation, and the fact that we're reducing component deterioration. So the last point, just moving on, I know I need to watch for the time, is our mass spring systems. So the mass spring systems are also known as floating slab. You can either have it as a full surface mass spring system, you can have it as strip bearings, or you can have it as point bearings. And now I've just included some images from some projects that we've been involved in. Project over in Switzerland, and you can see the installation is very similar to the underballast mat. You want the ballast mat down, glued and taped. And when it comes to slab track, you're really isolating, you're separating that slab track from the outer surroundings. So you're really isolating it, and the material can then absorb any of the vibrations and stop them from flowing out the way. Some more pictures here. And you can also see you can pour the concrete. It's not just for precast. You can also pour the concrete on site as well. Project in Austria, project in Ecuador, with the strip or point bearings, you can see they're placed down. The precast is placed on top. Project over in Brazil. One in Spain, Munich over in Germany, and what's also possible, and I'm sure they've done this with Crossrail, was you can jack the track up and put the material in. And to give you an idea of how it works, I'm hoping this little video will play it. And I don't know if it will. Right, it doesn't seem to be playing at the moment, but what you would have seen there is the vibrations or the movement of the slab above, and the purple pad depressing, normally is the correct word, which happens, so that really absorbs all the vibrations and movement. So it adds the elasticity, but it's defined and absorbs any of the vibrations from travelling out the way. So just to kind of finish up, we have different materials, different solutions for all different types of track, sections of track, and there's a varying possibilities depending on what's required. If there's a lot of noise and vibration needing to be mitigated, you might be looking at a more expensive solution, but with investment comes efficiency. All the way from rail pads to floating slab track. And in the end, what we are as a company are saying that by adding these elastic components to a standard superstructure, you end up with a more sustainable and more silent superstructure. And that's for me. Thank you very much. And if anyone has any questions, we'd be delighted to answer them.
Indeed, that was absolutely fascinating. Really beautifully illustrated as well, if you don't know what I'm saying. Shall we start off in the room? Would anybody in the room like to ask Andy any questions about this presentation?
How much has it been applied in the high-speed railways in Europe to their conventional or high-speed lines?
Yeah, not a good question. Unfortunately, I probably don't know the answer to a lot of them. I know there's a lot of work going on. Is it the Tranmere line? There's a lot of work over in Turkey. Of course, it depends on the track type. If it's ballasted track, then you're looking at slipper pads. But we are seeing growth internationally. I don't know if Brenner knows much about the high-speed lines as such, but we do have a lot of projects.
100% in Turkey, 100% in France, 100% in Italy, 100% Germany. Nothing in Austria because we have no high speed. So, yeah, really these countries I know
Yes,
that
it's
they
interesting.
use 100%.
The decision on the high-speed line in England has gone to slab track. Is that correct now?
Yep.
And I was just wondering the offset between deciding on slab track versus the relative use of under sleeper mats on a conventional construction.
Yeah.
I think the most impressive one is the recent world speed world record that they achieved in China with 100% China technology, they said, but there were our pets in there.
And was that on ballasted track or on slab track?
Too much. I don't know. I can't tell you.
Because intuitively, you'd think, wouldn't you, that ballasted with pads is more economic. Certainly at installation. And I guess it's a question of the maths during the life cycle of the track, isn't it, and how long the slabs can last.
Yeah.
Because nearly universally, the way you're applying it, it's actually constructed with the sleeper construction. That's part of the concrete sleeper production.
Yeah.
Yes, you're not retrofitting it at all.
They can be glued.
Yeah.
They can be glued. They're glued onto the likes of steel hollow bearers. And they can be glued if you've got the sleeper pre-existing for whatever reason. If you've forgot to add that when you're doing the ordering, then it is possible. The pad just comes out without the connection layer that normally goes into the concrete.
Yes.
Instead, it's smooth, so it gets glued on. So yeah, it's definitely possible.
So that's not done too often then.
No, the main aim, the design of them is to be done in the sleeper factory. It makes more sense that way. But if you have pre-existing sleepers and need to protect them for any reason, you want to use them again, or you already, you've created them and forgot to order them, it can be done.
A question from the chat. Are we going to try and let people pose it orally, Andy, do you think? Or...
Yeah, let's have a go and go
so,
on.
Bob Hazel, would you like to pose a question?
Just a little recognition.
Yeah, thank you, Andy. A great presentation. Talking to one of the converted, I have to say, we installed some undersleeper pads back in BR days in City Thameslink through the platforms at City Thameslink, which would have been in the 80s. And I'm aware that for 20 years we never had to tamp that. Admittedly, it was relatively low speed, and I don't know if it was a Getzner product, but it was certainly an undersleeper pad, and it was really effective. So that partly proved the benefits. And we also used your product at Shortlands when we put the dive under in there to insulate the structure there. But the thing that shocked me or surprised me within your presentation was the details on how much of the product is being used on each of the various different regions across Network Rail. And the really significant one for me was that East Coast seemed to have had very little take up, whereas I would have thought that a high speed route like that, it would have been really beneficial. And disappointingly, Anglia on my doorstep has got very little take up as well. Any views on why that is, Andy?
Because I've not done my job well enough over in those areas.
I suspect there's more to it than that.
No, there's different arguments for there's an installation cost, so there's an additional cost install. But are the benefits being met or understood that you? I think someone from I think it was Mohammed Webby again that said that the payback for a use of an undersewer pad is within 3 years. So once you've installed it, once it's in the track for 3 years, after that you're gaining everything. The costs are covered. It's my job to kind of look at where we're being installed, where they're not, and try and increase the knowledge of what all the benefits. But I don't have an answer to why they're not currently. I know there's pressures on, I think there's minimum viable product. I've heard quite a lot recently coming from the railway. But I do believe, and many others believe, that sleeper pads should be part of that minimum viable product. Because I think it's very clear what they can do and what they achieve.
Thanks for that, Andy.
Oh, thank you.
As we enter the Southern Renewals Enterprise, which is commencing from the 1st of April, I hear a lot of discussion of looking for best engineering solution and not just being driven by a minimum viable product. There's a lot of constructive discussion around that, not just being driven by the lowest absolute initial cost. So
Yeah.
hopefully wisdom prevails where there's the engineering benefit to justify it.
Because it's the whole track access question again, isn't it, Paul? On top of that. So not only the sort of life cycle thing, but can you actually deliver the maintenance is the other challenge these days.
Goes back to the whole life cost, doesn't it? Which
Yeah.
we used to use.
It's a really interesting point, Andy. I think that's becoming more acute. We're ultimately trying to fit more activities into the same access. Arguments are being had to try and increase access even for maintenance activities, but that's a challenge because people want to run trains because that creates revenue, of course. So it's a trade for that. But we're fitting more and more into what available access that we've got. So hopefully solutions that deliver less need for less maintenance intervention can be pursued sensibly.
Yes. Yeah. Can you tell us anything about how the sleepers perform in automatic track relaying equipment? Are there any issues around that, or are they so well fixed to the sleeper that it really doesn't matter how you install them?
Is this like the high output?
Like the high
hybrid.
yeah.
I've never experienced or been told they have any issues because they're on the bottom. It's just the way they're stacked, the way they're stored. It's not.
It lays on the conveyor belt,
Yeah.
drops it in, so it shouldn't-
Yeah. So it shouldn't be any different from a standard sleeper. The question has come up before, but again, I've never once heard of any problems.
It's a good point that Mr. Jones raised that actually, because in terms of getting the maximum benefit, getting that efficiency right through the delivery, albeit the strategy we're currently taking with high output nationally, that's potentially one of the best ways of realizing those benefits and delivery is really clearly demonstrating that, you know, that application and the fact that there are no concerns if that's the case.
Yeah.
I don't see any more questions on Teams, and I was going to chip in with a couple. That's okay. No problem. So for benefit, Andy, I'm Tony Newton. I'm the senior asset engineer and the head of asset team for Wessex.
Right.
And as part of one of our strategies around predict and prevent, we're rolling out remote condition monitors across S&C units across the route, and we're talking about the business space, what we're going to do in the future in CP7. And if it hasn't already been done, I think I want to do this. But has there been anywhere where void monitoring or accelerometers have been placed on S&C units in use on live railway and tracks, you know, the comparative between before and after a renewal with flat?
Yeah, I'm sure we will have the data from other countries. Is this the Conux blocks that you're
I
now?
wasn't going to mention specific suppliers, because we're currently deciding who we want to go with and the rest of that. But yeah, that's one of the suppliers.
Right, I've seen them kind of. I go to the PWI conferences, and I know they're doing quite well in the market. I don't have any information from Network Rail. One thing I've always struggled with, so I never say this, that I've worked for Getzner for just over a year now, but I worked for the sales partner for 6 years. So I've been pushing the benefits for quite a while. And what I always wanted was information back from Network Rail to say, look, I've heard on the call they installed and they never tamped for 20 years. I find it very difficult to gain that information. I know there's track analysing vehicles going around the track and gaining all the data. I would love that data. I would love to take that back and show, but I've never been shared. It's never been shared with me personally. So to answer your question, the likes of the monitoring box, the void box, I've never seen information, but I'm sure I can get results from other countries within Europe and further wide.
So yeah, so taking it on face value, I don't know why we're not doing this, and we are, to be fair, and Paul's made that point, but specifying that as a key requirement. But what would help with that decision, and I'm thinking the same myself, and in conversation with Dave and Ross, is that breakdown of the cost. So what does it actually add on to the cost of production of a sleeper to add the pads to it?
Yeah.
And what are we actually, and that breakdown of the need to replace the ballast and the life cycle of the whole unit. So what does it do to the composite kilometre cost, the unit rate we use for delivering renewals?
Yeah.
And then the other end of it, which is really, really important now as part of CP7, CP8 strategy, is sustainability and recovery of materials. So the whole life cycle, the circular economy, as opposed to just chucking it out.
Yep.
What's the experience so far of recovering those materials once it gets to the end of the life cycle?
Yep. So the materials, we need the bond between the pad and the sleeper to be so strong that it lasts for the lifetime of it. But at the very end, we need to be able to kick it off.
Yeah.
So it makes it slightly difficult. But with that said, they can be mechanically removed. And we've actually started a new company that's fully focused on recycling. There's different ways of doing it, trying to take the materials that were used to create the product back out, or like almost crushing or slicing and cutting, so it's turned into lots and lots of little bits.
Yeah.
And then using a polyurethane glue to then have a granulized material. So we already have some of these products were produced. They're in, and we're further developing them, not all the time. But yeah, certainly recycling is something we can definitely do.
Okay, and is it virgin material going in at the start, or
Yes.
is any of that recovered or recycled?
Yes. It's about 90% virgin material that you need to get 10% recycled material with a high investment of energy.
Yeah. Okay. That might be for some people a bit of the challenge, because arguably there's enough plastic in the world, there's materials out, but arguably the material sustainability and carbon emissions of replacing the track at short intervals, you know, there's something to, but that would be really good to know. That would be that's a key part of most renewal strategies now for sourcing materials. And going back to what Paul said under the Southern Integrated Delivery, sustainability is a really key part of selection of materials and design solutions.
Yeah.
So it's one of the measures of the output of decision making around the, what they call it, the enhanced profit word for the suppliers. I remember that being some conversation. But yeah, I've got your contacts, so definitely want to follow up.
Yeah, no, definitely get in touch, and we'll get a conversation going. I was sent a document. I'm not using it yet. I have the meeting on Friday, I think, with the person who created it. But it was a study by Network Rail, and it looked at the 40-year lifespan of the rail, and it showed you all the maintenance that needs to be done over that period, the tamping intervals, the grinding, the re-railing, all of these things for 660 yards. And then compared it with having undersewer pads. So I still have to have the discussion to find out how accurate it is, and before I start sharing any information. But if over 40 years, I'm sure it saved over £700,000, and that was only for 660 yards of track, which is a very small amount of track. If you multiply that, but going back to the sustainability point, I would like to do the same study, but using CO2, using carbon, and that kind of way. So no, I'd be happy to discuss further.
Yeah, definitely.
Excuse me if I was trying to find guests, but if I missed this.
Not at all, not at all.
But have you had much recent experience of using them in combination with composite sleepers instead of concrete sleepers?
So New York Crossing, quite famous composite crossing, has our pads on it. They were glued on. In terms of sleeper renewals, we've not really seen an uptake. I can't think of many projects recently that has them.
Probably not been that many recently, I think.
Yeah.
Again, the underground, I think, are using more than we're using.
Yeah. Yeah. I know that certainly composites are replacing timber, and the wooden sleepers in Network Rail, and the lateral track resistance tests you've seen from Southampton, they're now going to test composites with their pad to see how the lateral track resistance is for that. But yeah.
Presumably that's glued on.
Yeah.
That introduces another element, doesn't it?
Yeah.
The shear force between the
Mhm.
pad and the sleeper.
Yeah.
I've got one last question.
Yeah.
So a bit of a hot topic within the route is noise complaints. And rail wheel interface in certain locations, very influential people live with them. I'm not quite clear on the question myself, so that's what I thought I'd ask you. General vibration, talked about that in attenuation, where you get essentially rail squeal and that vibration on tight radii curves. Have you got any studies around that, and if that does anything around attenuation and noise and vibration, those things?
See, this one is more for some of my engineering colleagues. They are more experts, but what we are finding, we have products, so as you can see, you can mitigate noise by noise and ground-borne vibrations through the use of our materials. But it depends what's already there that's probably causing the problem. So if you have the problem with the kind of rail grinding corrugation, the first thing I would be looking at is the fastening system and the rail pad. If there's elasticity in there, I always think of it as the rail, the bending line of the rail. It's just over the shorter area. Whereas if you increase it by the elasticity being further down the track, you're adding the elasticity throughout the whole system. But it would be better placed question for one of my engineers. I wouldn't. I would love
that question.
Yeah, I'd like to follow up with you if that's all right.
No, absolutely. Could I just pitch in a couple as well? I'd quite happily take you guys down the pub afterwards and carry this on. But before that, just building on what Tony had to say there, have you got any information about the impact on vibration on the point operating equipment when you put under bearer pads in S&C? Does it reduce the vibrations that the point operating equipment see?
Point operating equipment. So anything that is in near contact of the track, so you're instantly reducing the vibration is travelling through. So from the sleeper onto the ballast, if the sleeper pad is absorbing some of that, then it's instantly. But by point operating equipment,
Well, the point machine or the high
It's attached to the sleeper.
attached to the sleeper usually.
Yeah.
And vibration is one of the things that in the end causes those, or can cause those things to fail. So maybe there's a benefit there as well, because the reliability of the point operating equipment is one of the most important things around.
Yeah. Again, I'm going to have to follow up, I'm afraid. It's not a question that's been asked to me before.
Really?
And the
Yeah.
point
Well,
operating.
there's so many suppliers out there for drive motors and torsion drives that they do the waveform on the traces that we monitor through our intelligent infrastructure team. So I'd probably say if you've already got contacts sending with the intelligent infrastructure network rail, to have a chat with them, because they monitor everything. It's not just track discipline.
Right.
And they're looking at things like that. And that's an old practice, to be fair, about remote monitoring of drive equipment. But locations where we've previously had non-undersleeper pads and where we have renewed with S&C in this case, that's an opportunity there.
Yeah.
I've got just one more sneaky one as well. So in terms of the manufacturing process and your pads going to the sleeper supplier.
Yep.
Is there anything that we should understand about the most economic way to do that in terms of production runs and so on, and whether that has any sort of influence on?
We aim to deliver full lorries, full pallets. Is that kind of
Well, it's that sort of thing.
Yeah.
Or within the plant itself, like are there minimum runs that are more worthwhile, or?
The only thing I can think of straight away off the top of my head is the delivery of, certainly for in the UK, full lorries, full pallets. We've changed the packaging to recycled cardboard. We're trying to do even the pallets themselves. Look at different variations to lower the carbon footprint essentially.
Yeah.
In terms of in factory, I think efficiency is what we aim for.
Yeah.
Rather than, but I'm not too sure how to answer.
Yes,
I'm just sort of thinking like for half the year they make sleepers without concrete, without the USBs, and half the year it's that sort of thing rather than 1 week they are, 1 week they're not. Sort of, whether that has any influence on the cost of it at all.
Yeah, for the actual sleeper manufacturer, it really comes down to their orders, the orders they receive from as and when. But in terms of installation, I don't think it would change much by doing half and half or throughout the year.
planning is key in general.
Yeah.
The earlier we know, and the clearer the quantities are, the better it is for us to react. And that is sometimes a challenge to get numbers, to get previews and plans. But that's not a UK problem, that's a worldwide problem.
Is the material manufactured? Where is the material actually manufactured?
In Austria.
In Austria,
yeah. At the headquarters.
Good.
not China.
Nope.
I'm really sorry that we're having to end this conversation. Actually, it's absolutely fascinating, and thank you so much for coming here tonight and giving us your presentation.
Thank you.
And thank you very much as well to Reinhard for coming on. I really appreciate you coming on to tell us.
It was a pleasure.
And it's really nice to talk about, if you like, a little bit of the cutting edge of railway technology, and you made it very easy to understand. So thank you very much indeed.
Thank you.
If online people, you're now allowed to turn your microphones on so that we can give them a round of applause. Thank you very much.
Thank you. Well, thank you very much. Should I change anything on this, or you're right? Right.
Oh, it's interesting that it's taken a long. How long have we had concrete sleepers?
60s.
So it's been taking a long time, but this is really, it's ballast attrition and the natural sleeper